Hi, I'm Masai. Today I'm going to talk about eye-based interactions using the smart eyewear, which is now I'm wearing this device. The eyewear device has XB and two big microcontrollers, and the sensors on the frame are very tiny. First, I will show you the demo of the device. For this demo, it is beyond the paper, but we use the upgraded version of the eyewear and CNN for eye direction detection. The device recognizes dynamic eye direction gestures regardless of facial expression states. Of course, the device can classify facial expression states. We used 16 optical sensors which measure the skin deformation through reflective intensity. Depending on facial expression states, the sensor values change. Also, the eye movement makes skin deformations, which change the sensor values as well. The sensor works like the proximity sensors, and the eyeball movement changes the shape of the skin and the eyelids. This changes the distance between the sensors and the skin surface. Unfortunately, I was not able to go to Germany and present physically, and I think there are more and more opportunities to present remotely in the future. And to communicate effectively, face plays an important role by combining non-verbal meaning, such as intentions and emotions. But some of us do not want to show your face during the presentation. In that case, one solution is virtual avatar. A device could be used to reflect your facial expressions into the avatar, and with this research contribution, your eye movement can be also reflected, which enriches the communication. So another application of the device is hands-free and stressless simple interaction in daily life, such as turning the pages of ebooks or turning on and off a heater. Of course, there are many techniques explored to measure eye movements using the wearable devices. We take two axes. One is usability, wearability, comfortability, social acceptability, and the price. And second is resolution of eye movements or accuracy and precision. Our paper stands on the left top because EOG-based method requires contact and the camera-based methods are more robust but usually expensive. So advantage of our method is wearable and socially acceptable and comfortable to wear. And it is simply implementation with low-cost sensors. To confirm the potential, we evaluated three eye-based interactions using the device. For gesture set, we choose simple gestures and also dynamic gestures to avoid unconscious input. We collected the 210 data using this software from each of 9 participants. 7 kinds of gestures, 10 times each on 3 different facial expression states. We used dynamic time warping as a distance matrix and pick up the closest gesture from each gesture's template. Template was made by just averaging the data on training set. For the classification of eye gestures, 89.1% with user-dependent training. There's no so much difference depending on facial expression states. And 17.5% with user-independent training. Dynamic gestures have potential for no or few user training use. Now let's move on to eye gaze experiment. So we have tested with how accurate the eye gaze can be detected. We asked 5 users to look at the colored rectangle 5 times. We categorized each user's data into 5 groups for vertical and horizontal respectively. Then we applied 5-fold cross-validation with the SBM. The horizontal axis has 10 degrees and the accuracy was 58.8%. The vertical axis has 5 degrees and the accuracy was 82.4%. For the reading detection experiment, one participant read 10 English jokes. Jokes were chosen to induce smiles. He let the text show on the screen. We introduced three examples. We applied fast ICA and peak detection algorithm to the sensor data. We manually checked the data and video and found the correspondence. If there was no facial response, we could detect the line breaks and blinks accurately. Second example, so it is still possible to detect line breaks and blinks while detecting the changes in facial expression. We can see the back circles that are related to look back the words from the sensor data. If there was user's movement, line breaks and the blinks detection got worse, but it is still possible to extract the facial expression changes. This shows the potential for automatic tagging and context analysis using the device. Head motion has an influence on sensor data, but could be compensated with IMU. But in outdoors, it really makes the data noisy because sunlight is intense. We may consider a trigger command to avoid false positives. We are exploring a sophisticated algorithm or deep learning approach to detect gestures and improve accuracy, but have the cost of latency. So to summarize, we showed that eyewear device with optical sensors could classify eye gestures regardless of facial expression states. And also we showed the potential of the device to approximately track the direction of the eyes. And finally, we showed that the device could be used to analyze eye movements and facial expressions in daily context reading. Thank you for listening.